Okay, guys, so this is experiment number 6, and in this experiment, we will learn about how to design a multiplexer using NAND gate. 4 is to 1 multiplexer, and 1 is to 4 TMUX using NAND gate. DMUX you have to do in homework, and multiplexer I will do right now in MULTISIM. Okay, I will write here in MULTISIM. Okay, so you know about what multiplexer do and don't, what DMUX do and don't, and how design works. So as you can see, this is 4 is to 1 multiplexer, 4 input, 2 select lines, and 1 output. So the truth table is like this. These select lines will select the output, it will select the input, and it will provide it with the output. As you can see here, when my select lines will be on 0 0, then my first input I0 I naught will be selected, and the output will be I naught. When my select lines will be 0 1, then I1 will be selected and output will be I1. Like this, it follows this equation. Okay, S1 bar S naught bar I naught plus S1 bar S naught I1, like this. So we have to design this MUX, okay, using NAND gate. How we will do that? So I have provided the circuit here. You can see this is the circuit of MUX using NAND gate. We will use this one NAND gate, two input NAND gates. We need one enable input NAND gate also. Okay, this is just for enabling the input, just for enabling, nothing else. Enable means when it will be 0, then it will not work. When it will be 1, then it will work, like this, just for that. And as you can see, this is I0, I1, I2, I3, which is connected to NAND gate, and actually this is 4 input NAND gate. As you can see, it has 4 inputs. Okay, it has 4 inputs, and all these are 4 input NAND gate, and this is also a 4 input NAND gate. So all the 4 inputs, one input from S1, S0, enable, and I0, it will go into this NAND gate, and the output of this NAND gate will go into input of this NAND gate, and final output Y we will get it here. So this is the circuit, and this is actually the DMUX circuit. DMUX circuit. Nothing means this is very simple circuit. It is just the DMUX. Okay, but you have to implement this one. I'm not going to implement this. I will implement this right now in this class using multisim. Okay, so now we will open multisim and we will implement this one. I will keep the circuit on this side. Okay. Make it small. Okay. So yeah, I will delete this one. Now, first what we need components. So we will go for the components, and what we will search here, what we need first 2 input NAND gate, 3 2 input NAND gates. Okay, so NAND, I need 3 2 input NAND gate. Okay, so 1, we'll place it here, 2 and 3 input NAND gate. Okay, then 2 3 input NAND gate, then this 4 input NAND gate, which will be here, 1 2 3 and 4. Okay, so and one more NAND will be here. Here it will come. Okay. So NAND requirement is done. Now we need okay. So now okay. So these are the NAND gates we are going to use. Now we need to connect the inputs, this I0, I1, I2, I3, and S1, S0, and enable as the select lines. What we will do for that, we will go for the switch, SPDT switch. Okay, so we need 3 switches here. Okay, we need 4 switches here. Okay, so this is done. Now we need VCC. One VCC will be here, kept it here, and one ground will be there. Now one ground will be there. Okay, so I will keep this ground on this place. Fine. So next thing is we need output where we will see the output. We can see in top blue. We can use instead of prop blue, we can use LED also, but for LED we have to connect one ground with it. That's why I'm using prop here. It's easy to use and circuit is simple. Okay. Keep it here. Okay. So now we have to connect the circuit. First, okay, we will rotate this one like this. Rotate this one. Rotate this one. And rotate this one. Okay. This is my ground. We will change its name. This one I will give A, no problem. Okay, keep it as A. Okay, now, no, no, this one is A, select this one. Yeah. This one is B, this one is C, and this one is D. So this A, B, C, D is like I naught, I1. This is I naught. A will represent as I naught. B is the I1. C is the I2, and D is the I3. Okay, and okay, so this is the. I will rotate this one also. Yeah. No, sorry. Yeah. Now it's okay. This one also, and this one also. And you can make this one as level it as, yeah, S1 is okay. No, this one will act as S1. Yeah, S1 is okay. This will act as S0. Okay, so S0 is okay, and this will act as enable. Okay, so I will give it as E. Right. So space. I think I will change this one from space to, I will change it to E only. Where is the E? This is E. Okay, we'll change it as this one I will give F. Okay, this one I will give G. Okay, so, and we can change this name also. I0. Act as I0. This will act as I1. I0, I1. Okay, I2, and this is I3. Okay, so this is done. Maintain some space in between. Yeah, that's okay. Oh no, I have to rotate this one also. Yeah, rotate this one also. Rotate this one also. Fine. Now, yeah, move little bit. Move it here. Little. Yeah, this one also. Okay, so connect the wires now. First, you start with this. input will be connected to this, second also will be connected to this, and one will go directly to I3. You can see here this input coming from here, it is connected to this one. This is S1, normal S1, and this is S1 bar. Okay, this NAND gate is working as inverter. So normal S1, S1 bar. So what we will do first, we will, okay, leave this one right now. Just connect this to and connect one input from here to here. Okay, this to here to here. Now what we will do, can we will leave one input as it is. We will take output as it is. Leave it till here. Okay, as it is. We will leave it till here. Okay, and we will take one output from no. Okay, one output from here. I will take and I will leave it till here. Okay, no. And now I will take. Okay, I will color this one as, I will make it a different color for this. Okay, so now I will make one different color for this also. This is and for this one also. This is okay. Okay, so this one is S0, S1, S0, and this is enable, like it is here. Now what we have to do, we have to connect this. Yeah. Okay, so this first input will go and connect to S1. First input will connect to S1. Okay, connected. Second is connected to S1 bar. Second is connected to S0 bar, because in our equation this third is for enable and fourth is for I0. Okay, sorry. We will connect like this. See, S1 bar, S0 bar, I0, and one enable is there. So enable will become 1. Okay. This enable will become 1. So when it will become 1, when we will give 0 as the input. Right? Now the second is S1 bar. This to S0 here. This is directly connected to S0, not S1. Now next is, third one is to enable. Third one will always go to enable. Okay, and fourth one is for the I1. Okay, now this third input, first one is connected to normal S1. Okay, first one is connected to S1. Second one is connected to S0 bar. Sorry. Connected to S0 bar. Okay. Now third one is for enable, and fourth one is for I2. Okay. Now the last one. for S1, second one will also go for S1, third one is the enable, and the fourth one is for I3. So you can see S1, S0 and I3. This is in our equation. S1, you can see it here, S1, S0 and I3. This is I3 actually. Okay. So like that we have connected the circuit. And now what we will do, we will connect this to one input. This will become our second input. This will become our third input. And this will be our fourth input. Okay. And this will be connected to prop. So now we have to give the input. I will give it. I will give the input. First of all, connect this one to this. I will copy this one and I will use it here. Okay. Okay, so my all the inputs are connected to VCC and ground. These are the select lines, VCC and ground, and this is my input I0, I1, I2, I3. All are connected to VCC and ground. Okay, so my circuit is complete now. This is our 4 to 1 multiplexer. Now we will check the output. How we will check the output? We have to keep S1 and S2 on 0, and then we will see Y as I0. So this is my Y output, and my I0 is on 1 because it is connected to VCC right now, and I1 is on 0, I2 is on 0, I3 is on 0. This S1 is now connected to ground. This S0 is also on ground, and for enable we have to keep this on ground because 0 we will give, then it will give 1 and it will activate this NAND gate. Okay, so all the circuits input we have given. Now we will run the simulation. This S1 is on 0. Okay. Okay, so my circuit is completed now. I have connected this S1. We will check the output after running the simulation. Okay, so there is some problem with the circuit, I think. We are not getting the output, proper output, because my I0 is on 1. Okay, sorry. S1 was on 0. That's why we are not getting. So right now my S1 is on 1. S0 is on 1. Enable, always enable. So I am getting I0 as output because you can see I0 is on 1 and we are getting 1 as the output. Now what we will do? We will see the second output, which is 0 and 1. So 0 and 1. First we will change this to 0. See, it becomes 0. If we will change this to 1, it becomes 1. So this is how we have checked that we are getting proper output. I0 as the output. These will not affect our output. You can see all these input will not affect our output because right now it's showing only I0. Okay. Now we will check for I1. For I1, we will give I1 as 1. All the other inputs as 0. And the select line will be on 0 and 1. So this will become 0 and this will become, sorry, this will become 1. What happened? Okay, so sorry. This will be on 0. Yeah, you can see S1 is on 0, S0 is on 1. Okay, S1 is on 0, S0 is on 1. So you can see for I1 it's giving the output. You can change the I1, then it will output. I1 is connected to ground now. If we will connect to 1, it will give output. Same thing for both 1 1, for both 1 1. This will be your I3 will be the output. You can see the I3 is 0 right now, and if we will give 1, see, it will become 1. I2 or I1, all these things, all these inputs will not affect this output. Okay, this is how we design a multiplexer in MULTISIM using NAND gate. Oh, and you have to design MUX like this only. Okay, and submit it in report. Fine. So that's all for today.